You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
Hello, Chris.
Hey, good morning.
Are you well?
Yeah, very good, thank you very much. Excited and raring to go, and I've had my coffee, so I feel like you. Lots of energy, but I won't be lapsing into sex speak, I hope.
Well,
Unless you want to, of course.
We'll get there later, yeah. People have been saying all sorts of weird things. There's a tropical storm on its way that's causing havoc with our brains here in South Africa. For years, Chris, we've abused the oceans and used them as dumping grounds for everything from plastics to chemicals, industrial waste, and you've got a story for us related to that.
Yep. Well, as the human population rises, there are more and more people living on the same or diminishing areas of livable, habitable land, and many of those people don't have any sanitation, and this means that the sewage they produce ends up going straight into the ocean, and it's often the same ocean they depend upon for their livelihood. And if they're contaminating it with human bugs, when they go in the water, they pick up those human bugs, and that makes them less healthy. So is there a way of actually cleaning up the ocean and keeping the humans safe, but also making sure we don't wreck the ocean ecology at the same time? Things like corals and other ocean species are being destroyed by the fact that they don't like living in contaminated water either. So this paper, which is out in the journal Science from researchers at the University of Cornell in America, really caught my eye this week. Drew Harville and her colleagues have been studying a number of islands in Indonesia, and they noticed that where there are seagrasses growing, there are very much lower levels of what we regard as pathogenic bacteria in those patches of water. Now, seagrasses are interesting species. They are direct descendants of the grasses we have on land, and they're interesting plants because about 400 million years ago or so, these plants, which evolved originally in the ocean, moved out of the ocean and onto land. They developed flowering mechanisms and they set seeds, but then a while later they evolved to go back underwater, and they now live in the sea. And they provide a habitat for lots of different species, invertebrates and crabs and sponges and so on. They're really important, but they still flower underwater and they still set seeds underwater. So they're effectively land plants that have learned to live underwater again. But how they do this amazing detoxification, the researchers aren't sure. They did a carefully controlled study where they compared the numbers of bacteria in the water where there were these seagrasses and where there weren't. And where the seagrasses are, there's a 50% reduction in the bacterial burden in the water. And this includes bacteria which are coming from the guts of human beings and can cause us to become ill if we ingest them. Now, I spoke to Drew Harville, and she speculates that it could be that there are filter feeders like sponges and shellfish living in amongst the grass. They could be sucking the bacterial particles out of the water. Also, it could be that just the mere fact that these are plants and they're oxygenating the water, and oxygen is toxic to many of these bacterial species, that could play a role. But then she said something really intriguing, which is, well, the plants might make chemicals themselves that are toxic, but living on the plants is a microbiome. In the same way as we have bugs living on us that keep us healthy, the plants have their own bugs that live on them. And it may well be that living on these seagrasses is a population of bacteria which are directly toxic to pathogenic bacteria in the water. So the plants might be fighting our bugs with their bugs. And therefore, us looking at this is really important because we know we're facing an antibiotic apocalypse in the future. We're running out of antibiotics that will work effectively. Perhaps we can look at how the seagrasses are doing it, and in the course of helping to clean up the ocean and use these seagrasses perhaps to regenerate coral reefs that have been damaged by pollution and keep water safe, we might also find there's a solution to our own antibiotic crisis lurking underwater there too.
Absolutely fascinating. In the meantime, of course, we're allowed to stop actually dumping plastic and chemicals and waste. Let's go
and
to
especially sewage.
Absolutely, yeah. Let's go to Indonesia South. Our first caller today, Chris, is Brian. Hello, Brian.
Hi, good evening, studios. How are you?
We're very well, Brian. What's your question?
Okay. I just need to find out. I think when I was around 13 years old or so, I had this, whenever I would cut cheese, my fingers would burn. And then it just happened to my daughter last week again. For like 4 days, her fingers were burning nonstop. I just want to find out what is causing that.
Very good question. Chris?
Did you say chilies, as in chili peppers?
Yes, it is.
Yeah. Well, chilies have a chemical in their flesh which is called capsaicin. And capsaicin it's a chemical that binds onto the nerve fibres in your skin and eyes and mucous membranes, in other words, the damp, sensitive bits of your body, anywhere. And those nerve fibres, which are called C fibres, convey a sense of pain or burning. And they have on their surface a receptor, a chemical docking station, which is called TRPV1, TRPV1. And when the capsaicin molecule docks with that, binds onto it, it opens pores in the surface of the nerve cell and lets sodium pour into the nerve cell, and this activates the nerve cell. And this is the same thing that would happen if you were to burn or cut your skin. So in other words, this chemically fools your nervous system into thinking it's being burned or heated or cut or traumatized. So you get all the same sensations as though you really were injuring yourself, but it's a chemical trick, and that's not happening at all. And we interpret that sensation as a hot one. You can do a similar experiment. You've probably noticed if you've sucked on a mint and then breathed in cold air, your mouth feels very cold. In fact, if you put a thermometer in your mouth, the temperature doesn't change at all. This is a similar chemical trick. Menthol, and peppermint oils, which are in a lot of these mints, they bind to a similar chemical docking station. This one's called TRPM8, and when they activate that, it also activates the nerve fibre, but in this case it activates cold-sensing nerve fibres, fooling you into thinking your mouth is colder than it really is. So you get a cold sensation when you breathe in. Same trick. And this capsaicin stuff sits on the skin for ages. It's oil soluble, so you need to use some detergent or something to get it off. And that's why you will have that burning sensation. It will get through the skin and onto the pain fibres in your skin.
Let's go to Constantia. Good morning, Peter.
I've got a question. Morning. Where does the mercury come from in the large game fish found in the ocean?
Right, so why does mercury build up in
Where
fish?
does mercury come from? Yes, please.
Yeah, there's a range of sources. Mercury is a heavy element, Hg. It's found naturally on Earth, and you find it often in the same places as you find other heavy elements, so things like silver and gold. When you dig those up and extract them, you sometimes find traces of mercury there. In fact, that's why it was called quicksilver. And when we use mercury, because it's used in a lot of industrial processes, for example, in aluminium smelting, mercury was used, and in a range of different things, like the electrolysis of brine, you use mercury to create chlorine gas. So there's a whole range of industrial reasons why you would use mercury, and some of these things lead to mercury and other industrial processes getting into water. We were talking about marine pollution earlier. When it gets into water, it then gets filtered, picked up by small organisms in the seawater, bacteria, small invertebrates. They accumulate this stuff because they eat it just because they're living in the water. And because those things build it up in their body, when they're eaten by bigger things, it concentrates all of the mercury burden in the small thing into the bigger thing. And then when something bigger comes along and eats the bigger thing, then it gets all of the mercury dose that's in the bigger thing and gets an even bigger mercury dose, and so it goes up the food chain, and this is called concentration up the food chain. And that's why you see things that accumulate building up in long-lived big predators that sit at the top of the food chain, and big fish sit at the top of the food chain in the ocean.
Christine, what is your question?
Good day. Vodacom is planning to erect a 25-metre cell tower and base station in Vierde Park, a recreational area. I want to know how dangerous this will be to our health, as we already have 20 masts within a 5-kilometre radius.
Hello, Christine. Well, the answer is these stations use microwaves to communicate between themselves, each other, and also with your cell phone. And as far as we know, on the basis of current evidence, there is no evidence to link the radiation coming out of these masts and out of your phone with a health problem. Now, I'll counter that by saying at the moment, because we're doing a huge, great human experiment, there are billions of mobile phone devices, Wi-Fi devices, and etc. on Earth. We've only been using them in relatively recent times, so we've got a couple of decades worth of data now. But we know that certain diseases might take much longer than that to occur. So scientists are effectively doing a huge, great scientific human experiment. What they're doing, for example, is comparing rates of cancers of all types before, during and after people began to embrace these exposures to mobile phone signals. And at the moment, if you look at the graph of how many cases are cropping up and where every week, every year, every decade, all around the world, you cannot see any evidence that the graph is changing. There doesn't seem to be an increase in the rates of cancer, but the rates of exposure to these communications signals is rising exponentially. Now, normally, for something to cause something to happen, we have to apply what are called the Bradford Hill criteria of causation. And one of those criterion is that there is a dose-dependent relationship. In other words, if something causes cancer to happen, the more of it you're exposed to, the more cancer you should see. We're not seeing that at the moment with these mobile phone signals and emissions, so people are comfortable at the moment to continue cautiously, and obviously not to take unnecessary risks, but at the moment they're keeping an eye on things, but there does not appear to be any strong, compelling evidence linking exposure to a health problem, but they're watching it carefully.
Thank you, Christine. Let's go to Soweto. Hello, Tabang.
Hi, how are you, serious?
Very good, thanks. What's your question for the Naked Scientist?
Quick question. When I eat something spicy, before I even swallow it, my scalp will go itchy. I just want to find out what causes that.
Yeah, you get itchiness, people sweat as well. There is a lot of connections between the nerve fibres in your mouth and the reactions you have on your skin. So people, when they eat a very hot curry, for example, they've not even had time to absorb that curry into their bloodstream or the spicy food. It's just putting it in the mouth triggers that reaction. And it's part of the same reflex that, for instance, when you see a bright light, you might blink. The evidence that we have is that you put the stuff in your mouth, it triggers part of what's called your trigeminal nerve, which is the sensory nerve supplying your mouth and tongue. This feeds back into your central nervous system and does a range of things, including informing you about the texture and the temperature of food, but it also then triggers skin reactions, including things like sweating and itching in response to what you're eating. And that's why when you have a hot curry, you sweat profusely. It's not because you're getting too hot. It's triggering your nervous system and fooling it into thinking there's something very hot going on here. So it puts in place all these cooling you down mechanisms that you don't really actually need.
18 minutes after 10, if you've just joined us, this is, of course, The Naked Scientist. And if you have a question for Chris, give us a call on 011-883-0702 in Johannesburg and in Cape Town on 021-446-0567. You can also SMS us a question, 31567 or 31702. Chris, let's take a quick question from Twitter. Here is one. Ratlu says, "Morning News CBS, please ask The Naked Scientist, who names these cyclones and under what reasons or rules?"
Well, originally, it was all very sexist because they used to give them only the names of women. And this is because I think the rather old-fashioned people in America who came up with these names for these things thought that they would that women would in some way be more annoying. But now it's much fairer, and we use men's names and women's names. And the thing is, though, that people have now done studies on whether people take them seriously, and they've compared whether people rate a storm to be a very severe threat or not based on its name.
That's right.
So irrespective of whether it's bad, they just ask people, OK, you've got Hurricane Irene or you've got Hurricane Gulliver. Which do you think is going to be worse? And people will repeatedly say the male-named storm has a much greater risk attached to it than the female-named one. So they in some way regard female tropical storms as or female-named tropical storms as less malevolent than the male-named ones. And so now we're saying, well, actually, do we need to either educate people, bring people into the 21st century, or adopt a different naming system so people don't become complacent about them? But isn't that interesting that people think that the female storm will in some way be kinder and more considerate of your welfare than the male-named storm, which will just be more selfish?
No, I was trying to wreck my brain as I read this question. I thought that there was an interesting freakonomics fact about this. So there may be then a public interest or public health interest even in naming them after men after all.
Or just naming them in some way that doesn't create these or doesn't elicit these preconceived psychological issues.
Yes, absolutely. 21 minutes after 10. Let's take a quick break.
702 and Cape Talk.
The Naked Scientist.
Chris, here is a quintessentially South African question the nation would love you to answer, and it is courtesy of Kaya Kazi. Ask Chris, do white and black people have different body temperatures? I want to know because I'd love to know whether this office aircon warfare will ever end.
No, we're all human, and it doesn't actually matter what colour you are, then your physiology is very, very similar. I say very, very similar because genetically we're all different. Everyone on Earth, unless you have cloned yourself or you're one of identical twins or triplets, then you are genetically distinct, and therefore everyone's a bit different. But when you go to the doctor and we take your temperature to see if you have a fever, it should normally be about 37 degrees. Everyone's pretty much the same. That said, the reason that black skin evolved in the first place was to give our earliest ancestors defence against the hot African sun, because our earliest ancestors as modern humans evolved in Africa, around equatorial Africa, and the animals that we evolved from originally had pale skin because they had fur to protect them. But as we lost our body hair, people were being exposed, these early ancestors, to large amounts of solar radiation, ultraviolet, and this would have damaged the folic acid in the body. And folic acid is very important for making new cells, and you need it to have healthy babies. Babies that don't have enough folic acid when their nervous system is forming will get things like spina bifida, which is why all people trying for a baby are advised take folic acid supplements. If you have dark skin, it defends your body against the sunlight and stops it breaking down your folic acid. So people had to evolve to have dark skin to protect them. At the same time, they also evolved quintessentially classic African hair, because wandering around under the hot African sun would have made their head extremely hot, and this acts as a really excellent barrier, creating an air barrier between the outside air and the top of the head, so it's a good defence mechanism against getting too hot. So all of those adaptations conferred enormous resilience on our ancestors and made humans really successful as they are today, and gave them all of the ability to thrive in the environment in which they evolved.
Go to Cape Town. Is it Hassie or Hassie?
Hassie.
Hello, Hassie.
Hello there. Coincidentally, my question almost links to the very previous one. My question is, the body grows hairs all over in different areas, but each area will produce hair of a maximum length. So there are different lengths of hairs on different parts of the body. What determines that? I listen on the radio.
The way this works is that hairs have a number of phases in their life cycle. Hair comes from a hair follicle in the skin, which is a little ring of stem cells that produce the hair filament, and the hair grows during what's called the anagen phase. Anagen means growth. It then falls out after it's grown for a certain period of time. That's the catagen phase, like catabolism, breaking down. Then it has a resting phase, a telogen phase, for a while, and then the process resets. Now, the length the hair can grow to is therefore determined by the relative lengths of the anagen phase to everything else. If you compare hairs on different parts of the body, the hair follicles, you'll see that they go through cycles where their anagen phases are different. So a head hair, for instance, has an anagen phase when it's growing hair that may be 3 years or longer. Whereas if you look at an eyelash, if that grew for 3 years, we'd have a big problem. You wouldn't be able to see anything. So those hairs grow for about 3 weeks. If you look at a pubic hair, it's about the same. There are also some other differences with them being curly and so on. But those differences in relative growth length affect how long the hair can ultimately become, and that will therefore be adapted to which part of the body they're on, so they're fit for purpose.
Okay, here's a question from our SMS line. Anonymous wants to know, Chris, why do cows all face the same direction when grazing?
We don't know, and that sounds like it's a daft question, but it's not. It's absolutely true. There was a paper in the journal PNAS, Proceedings of the National Academy of Sciences. It was about 2008, 2009 time, I think, from memory. And these researchers didn't just look at cows, they managed to obtain satellite images of many different parts of the Earth's surface where there were ruminant animals, like cows, antelope as well, and they looked at how these animals organised themselves in the field. And they find that they do line up north-south more often than not. And we don't exactly know why they do that, but one theory is that if all the animals have adapted to line up perhaps with the Earth's magnetic field, what this does, because of the way their eyes work and the way their herding instincts work, perhaps it gives them an advantage over predatory animals that will have to come in. If they're forced to come in from the sides, the animals can see them. If they're forced to come in from behind, the animals can wheel around and get them, and they can look ahead as well. So it might be that predation has driven these big animals that need to stand there and chew cud for ages and live in big herds. It's given them a survival advantage if they all arrange themselves in one big line, because they'll spot predators sooner and they can defend themselves better and get away quicker.
Squeeze in one more. Let's go to Orange Grove. Paul also, good morning.
Hi, Chris. I need
Hi.
to find out gold. We have wood, we have steel, we have all that I use daily, that I see the use of. But gold, it seems to be the most precious one, or more precious than all of them. Why is it precious? Is it for jewelry? Why do I need gold in my life?
Well, there's a scientific answer to this, and then there's a practical answer to this. The scientific practical answer is that gold is an excellent conductor of electricity and it does not corrode. So people like to use gold in high-end audio equipment. So, for instance, all of the connections at Talk Radio 702 and 567 Cape Talk, a lot of those connections will be gold-plated, because it means that no one go in there and nick the cables, okay? The reason for this is that because it's an excellent conductor and it doesn't tarnish, you don't end up with oxide layers on the connections, so you don't end up with poor audio quality, which you'd never get from 702 anyway.
Of course not.
Now, in terms of why else we like it, it's rare, it's hard to get hold of, but it stays beautiful and shiny forever. Therefore, it makes great jewellery. It's quite soft and easy to work, and it's therefore a status symbol. So for years, people have taken this rare material, which looks good, doesn't go rusty or tarnish easily, and because it's turned into nice jewel that's easy to work, you can use it as a display of your own personal wealth. Because it's rare, it's hard to get hold of, so if you've got a lot of it, you must have a lot of resources to be able to get a lot of it, or be highly valued by other people, so they will help you get a lot of it. So it's a good status symbol.
On that beautiful note, Chris, thanks for sharing your knowledge and insights.
Thank you, Eusebius. It's been great questions. Bye, everybody. See you next time.
Cheers.